Hey everyone, it's time for us to do a little exercise. Our job here is going to be picking the best value of k. So I want you to create a loop to apply KNN with values of k ranging from 1 to 25. So far, we only tried with k equals 1. We had a very good result, but we don't know if this is the best one for our data set. So I want you to run this loop to try k values from 1 to 25, test the performance of each k value, and present the one that best suits our data set. So good luck, and when you're finished, come back here to see the result. Alright, if you started a new file for this, you're gonna have to import all the modules again. I'm just gonna do it here, so I don't have to import KNN, train test split, and metrics again. So the first thing I'm going to do is creating a dictionary that is going to store all values of k. So we can name it k values. For now, this is just an empty dictionary. We don't actually need a dictionary. We could use a list, but using a dictionary is going to be easier to do something that I want to do with this, which is generating a chart. So now let's start a variable called k. And this is going to start with k equals 1. So now we can just run a loop. So while k is less than or equal to 25, we are going to redefine KNN but instead of using 1 as the number of neighbors for the value of k, we're just going to use the k value we just created above. After doing this, we just use knn.fit. And here we can use the x train and y train. Then we have the predictions. Which is going to be knn.predict, and then x test. Now performance, we can just copy this, and now the first time we run this loop, we will have the performance for k equals 1, and we know that it's 98.333%. So now what we do with this is pushing this to our dictionary. So we have a dictionary called k values, and we are going to create a new key, and the key is going to be our value of k. So for k equals 1, we're going to store the performance. Since we have a lot of decimal places, let's do a round. And we can use 4 decimal places to make things cleaner. Now, at the end of this, we can just increment the value of k, and this is going to run up to 25. Now let's jump out of the loop, and before we go ahead, let's print this dictionary and see what we got here. So k values. Let's run this. Alright, this is pretty cool. So we have 25 values of k. It's going to be a bit hard to pick the best value of k because we can see that some of them, they had 100% accuracy, which means that the computer is having a very easy job on learning how to identify the species of an iris flower. Anyway, this is just for learning purposes, so let's go ahead. And now I'm still not happy with this way of presenting the result. So let's create a chart. We already learned how to do this. So let's import matplotlib.pyplot splt. Now we're gonna need 2 lists, and we only have 1 dictionary, so we can use a function called list, and we can get k values dot keys. So it is going to get all the keys from this dictionary and transform it into a list. So this is the first list we're going to use in the chart. And the second list, let's do more or less the same thing, but instead of getting the keys of the dictionary, we are going to get the values. So now we have two lists to create our chart. Now let's just put a label to the x-axis, which is going to be values of k. Let's do the same thing for the y-axis, which is going to be the performance. And now let's try to do plt.show. Now we could not show the chart because in Jupyter, in order to show the chart inside a cell, we need to use a %sign and do matplotlib inline. So by doing this, let's run again, and now we can see the chart. So we can see that we have very good results, but actually the best ones were above 10. So even though we had a lot of K values that reached 100%, it was interesting to see that any value below 10 is not going to give us the best results possible. So this is pretty cool. This is just an example. I just wanted to show you how to measure the performance of KNN, how to pick the best value for K, and of course, in real-life examples with bigger data sets and more complex problems, most likely you won't have results of 100%, but if you do the same thing, if you try different values of K, if you play with the training and testing groups, you can have some very good insights to have a better performance on your model. So I hope you like this exercise, and I'll see you in the next video.